Hello everyone. Can everyone hear me? Okay, I'm going to be continuing learning Linux again. So last time started studying the basics from the Linux Journey website. This stream I'm going to be doing the same thing. So change to full screen. Okay, this is my home page in my desktop. I was working on this. So default terminal testing. Then open it terminal. Okay. So Firefox. So last stream I finished these two. My laptop is really slow. This stream I will start with Textful. So okay. So let's just start it right away. By now we have become familiar with many commands and their output, and that brings us to our next subject, I/O. I/O streams. Let's run the following command and we will discuss how this works. So echo hello world peanuts.txt. So is there alt tab in Linux? Okay. So if we do ls, we have these files. We have echo testing in random.txt. And now we have ls. Wait, it has to be like this. Now if we do a list, we have random.txt. Now let's go to files. Open this. And it says testing. Now I can just echo it. Echo random.txt. No, not echo. Concatenate. Then I get testing. But if I do concatenate new document, I have this. What if I do echo blah new document.txt and then I do concatenate. Oh, it overwrites the content. What just happened? Well, check the directory where you ran that command, and lo and behold, you should see a file called peanuts.txt. Look inside that file and you should see the text hello world. Lots of things just happened in one command, so let's break it down. First, let's break down the first part, which is echo hello world. We know this prints out hello world to the screen, but how? Processes use I/O streams to receive input and return output. By default, the echo command takes the input from the keyboard and returns the output to the screen. So that's why when you type echo hello world in your shell, you get hello world on the screen. However, I/O redirection also allows us to change this default behavior, giving us greater file flexibility. Let's proceed to the next part of the command. This arrow is a redirection operator that allows us the change where output standard goes. It allows us to send the output of echo hello world to a file instead of the screen. If the file does not already exist, it will create it for us. However, if it does exist, it will overwrite it. And that's basically how std out redirection works. Let's say I didn't want to overwrite my peanuts. Luckily, there's a redirection output for that as well, which is a double arrow. So a double arrow, I'm guessing, is append. So echo more blah double arrow in the new document. Clear. Concatenate new document. Yeah, it appended. What redirector do you use to append output to a file? This correct answer. Try out a couple of commands. Echo hello world. I think this will clear out a file. Let's just see. Terminal, new document, concatenate, nothing. std in. In our previous lesson, we learned that we have different std out streams we can use, such as a file or the screen. Well, there are also different standard input streams we can use as well. We know that we have std in from devices like the keyboard, but we can use files output from other processors and terminal as well. Let's see an example. Let's use the peanuts.txt file in the previous lesson for this example. Remember, it had the text hello world in it. Just like we had this for std redirection, we can use this for std in redirection. Normally in the cat command, you send a file to it and that file becomes std in. In this case, we directed peanuts.txt to be our std in. Then the output of cat peanuts.txt, which would be hello world, gets redirected to another file called banana.txt. So concatenate. So wait. Terminal ls test.txt. Sorry, concatenate test.txt. I get all this. And if I do this test.txt, what happens? Nothing. We can use this for stdin redirection. Normally in the cat command, you send a file to it and that file becomes std in. In this case, we directed peanuts.txt to our std in. Then the output of concatenate peanuts.txt, which would be hello world, gets redirected to another file called banana.txt. Oh, what's the point of this though? So if I do concatenate .txt, wait, let's just add some echo some random text to new document and then concatenate new document, concatenate. I still don't understand the difference between the two. Nothing. Okay, so echo hello world appended to new document.txt. Now if I concatenate new document.txt, alright, now what I want to do, so I will create a file called I will create a new file, some more text to doc2.txt and then ls and then concatenate doc2.txt. Now echo, I want the information from new document to be appended to doc2. So if I want information instead of plain text, I want information from a file, I would use this. Now I can type new document and then append it to doc2.txt, and then ls doc2, no, concatenate doc2. I have okay, let's see, concatenate new document. Why is it doing that? If I do this, concatenate that to, okay, I actually don't know why it's doing that. Concatenate new document. Append it to doc2.txt and then concatenate doc2. Okay, this does what I was intending to do. So let's say echo some more text to doc2.txt and then we check what's inside, right? And now concatenate new document.txt with nothing, and then output goes appended here. And now concatenate. Yeah, this does what I wanted to do. Let's use peanuts.txt in the previous file for this lesson, for this example. Remember, it had the text hello world in it. And just like we had this for stdcr redirection, we can use this for stdin redirection. Normally in the cat command you send a file to it and that file becomes stdin. In this case we directed peanuts.txt to our stdin. Then the output of output of concatenate peanuts.txt, which would be hello world, gets redirected to another file called banana.txt. Print working directory. Okay, let's try. Echo new world.txt doc2.txt concatenate doc2. I don't understand what this is doing. It is new document.txt doc2.txt concatenate doc2 concatenate new document. So new document wouldn't change because it's an input. Well, what's the purpose of this? I could have just written ls without all of this and it still would have worked, right? Print working directory new document doc2.txt and concatenate doc2.txt. I didn't understand their examples. Let's try something a little different now. Let's try to list the contents of a directory that doesn't exist on the system and redirect the output to the peanuts.txt file again. What you should see is ls cannot access fake directory, no such file. Probably thinking shouldn't that message have been sent to a file? There's actually another IO stream in play here called the standard error. By default, std standard error sends its output to the screen as well. It's a completely different stream than std cout. I keep saying cout from C and C++. So you will need to redirect its output in a different way. Unfortunately, the redirector is not nice as using input output, but it's pretty close. We will have to use file descriptors. A file descriptor is a non-negative number that is used to access a file or stream. We will go into depth about this later, but for now, know that the file descriptor for std in, std out, and std error is 0, 1, 2 respectively. So now, if we want to redirect our std error to the file, we can do this. Okay, so if I do list that doesn't exist, do that to doc, it will say now 2. Now if I see what's inside doc, it's this. I'm assuming it works with append as well. And then I see what's inside doc. Yeah. This sense there is a, it's now what if I wanted to see both std error and std out in the peanuts.txt file? It's possible to do this with file descriptors as well. So this goes to peanuts. The result of this goes to peanuts.txt. And what's this? This result sends the result of ls fake directory to peanuts.txt file, and then it redirects standard error to standard output via 2 and 1. The order of operation here matters. 2 to 1 sends standard error to whatever standard output is pointing to. In this case, std out is pointing to a file. So 2 going to 1 also sends std error to a file. So if you open that peanuts.txt file, you should see both standard error and standard output. In our case, the above command only outputs standard error. Oh, like reference in C. There's a shorter way to redirect both standard output and standard error to a file. Now, what if I don't want, we just use ampersand. Now, what if I don't want any of the cruft and want to get rid of the standard error message completely? Well, you can also redirect output to a special file called def null, and it will discard any input. So discard any input. So ls to def null. Concatenate def null. What is def null? Is it like in the root directory? And wait, let's just see ls to we do ampersand doc to.txt and then see what's inside. Okay. Now ls test1. Now a correct output, we do it like this. Now we concatenate. Yeah, and then it shows this. What is the redirector for std error? It's to this pipe and tree. Let's get into some plumbing now. Not really, but kinda. Let's try a command. ls, la, etc. You should see a very long list of items. It's a little hard to read actually. Instead of redirecting this output to a file, wouldn't it be nice if we could just see the output in another command like less? Well, we can. So, okay. So we have LSLA, LSLA test 1. What is etc.? Do I have it? So long format, what was A? I forgot what A was. Oh, A shows all the hidden files, right? Like dot and two dots. LSLA, etc. less. What did less do? Hold on, home. I need a reference. I remember there was less and more, which shows instead of showing the whole output, it shows like a small amount of it. Command line less, like it will show it in pages. If you are viewing text file larger than a simple output, less is more. The text is displayed in a paged manner. So let's see, less. It's like this. Home. No, it's just etc. Less etc. is a directory. Go ahead and look at the contents of a file with the less. Oh, ls is used for files, for viewing text files. You should see a very long list of items. Instead of redirecting this output to a file, wouldn't it be nice if you could just see the output in another command like less? Well, we can. So ls and the pipe operator less, represented by a vertical bar, allows you to get the stdc out of a command and make that stdc into another process. In this case, we took the stdc out of ls, la, etc. and then piped it to the less command. The pipe command is extremely useful and we continue to use it for all eternity. Well, what if I wanted to write the output of my command to two different streams? That's possible with the t command. You should see the output of ls on your screen, and if you open up pinuts.txt file, you should see the same information. Okay. So we have this command, and the output is the input of less. Okay. We have ls, and the output of ls goes to t doc2.txt. So it outputs here and it outputs concatenate here as well. To two different streams. So T outputs over here and outputs to stdc out, right? Try the following commands. T banana peanuts pipe operator is this. So I'm guessing you have new document, concatenate new document, concatenate doc2. This is taking so much time to load. It's already loaded. Run the following command. You should see the path to your home directory. Mine looks like home Pete. So echo home. home VBox user. What about this command? You should see a username, echo user. Where is this information coming from? It's coming from your environment variables. You can see these. You can view these by typing environment. Environment. Now files doc2. Let's see. LS colors. Okay, these are environmental files. And then what else? This output a whole lot of information about the environment variables you currently have set. These variables contain useful information about the shell and other processes that the shell and other processes can use. Here is a short example. So path, print working directory, and user. So the environmental variable is different for each directory. So print working directory, okay. One particular important variable is the path variable. You can access these variables by sticking dollar in front of it, in front of the variable name like so. Echo path. So user local games, user bin, user local bin. This returns a list of paths separated by a colon that your system searches when it runs a command. Let's say you mining download install a package from the internet, but put it in a non-standard directory and want to run the command. You type $command and the prompt says command not found. Well, that's silly. You're looking at the binary in a folder and know it exists. What is happening is that path variable doesn't check that directory for this binary, so it's throwing an error. Let's say you had tons of binaries and you wanted to run out of that directory. You can modify the path variable to include the directory in your path environmental variable. How do you see environment? We are going to learn a couple of useful commands that you can use to process text. Before we get started, let's create a file that we'll be working with. Copy and paste the following command. Once you do that, add a tab in between lazy and dog. The quick brown fox. The quick brown fox jumps over the lazy dog. Sample.txt. Terminal. Echo. The quick brown fox. They said tab. Hold down Control V plus tab. Sample.txt. First command we'll be learning about is the cut command. It extracts portion of the text from the file. To extract contents by a list of characters, do this. Wait, they said copy and paste the following command. Once you do that, add a tab in between the lazy and dog. But I don't think the terminal allows. Brown. Doesn't allow tab. And so what did this say? Cut character 5 sample.txt. So cut character 5 sample.txt. So 1, 2, 3, 4, 5. This outputs the fifth character in each line of the file. In this case, it is Q. Okay, I mean in their case, it is Q. Wait, let's open. So open. Let's open sample.txt. Look like brown fox jumped over the dog. So we have Q and then we have E. To extract the contents by a field, we will need to do a little modification. So cut field to sample.txt. The if or field flag cuts text based off of fields. What do they mean by field? By default, it uses tabs as delimiter, so everything separated by a tab is considered a field. You should see dog as your output. So let's go to text editor, tab, and then another tab. Now cut field to fox and the. If I do 3, oh, it's trying to give every third field, the third field in every line. If I do 4, it's empty. 5, also empty. So it's just printing new line. First, yeah, this is the first field, this is the second field, and this is the third field. You should see dog as your output. You can combine the field flag with a delimiter flag to extract the contents by a custom delimiter. Delimiter space. Let's do every third. We have brown, we have fox, brown, fox jumped over the dog. Hold on. Let's do every second. So quick, and over the dog is considered a field. What does the foreign command do and why? Can we choose multiple characters? Hold on. Terminal space and J. Let's choose E. Let's concatenate sample.txt. So the jump, and then if we do every second, it skipped over E and printed this. And then D. Okay, so it ignored the first delimiter I mentioned. First character of every line in the file. So cut C1. The paste command is similar to the cut command. It merges lines together in a file. Let's create a new file with the following content. Let's combine all these lines into one line. Paste s sample2.txt. The default delimiter for paste is tab, so now there is one line with tab separating each word. Yeah, let's try it. So concatenate sample.txt and let's paste it now. What did it do? The paste command is similar. It merges lines together in a file. Let's create a new file. Why didn't it do anything? So now there is one line with tabs separating each word. What is the S for? Let's change this delimiter to something a little more readable. Now everything should be on one line, delimited by space. /s. Oh, this works. There's a tab after Fox. Well done. Text editor. Oh, they're using tab to separate the lines. Instead, we can add a delimiter. Let's say delimiter is this. Now we have this. Oh, what's the S? What is paste? Merge lines of a file. Manual paste. Merge lines of a file. Paste one file at a time instead of in parallel. Author, copyright. Display this help and exit. We use characters from list instead of tab. Write lines consisting of sequentially corresponding lines from each file separated by tabs to standard output. With no file or when a file is dash, read standard input. Mandatory arguments to long options are mandatory for short options too. So paste one file at a time instead of parallel. So I want to see how paste works with multiple files. Why doesn't this work? What flag do you use with paste to make everything go in one line? S. Head. Let's say we want to have a very long file. In fact, we have many to choose from. Go ahead and concatenate this. I think the commands should be in a different format, otherwise it can get confusing. You should see pages upon pages of text. Whenever you just wanted to see a first couple of lines in this text file, well, we can do that with the head command. By default, the head command will show you the first 10 lines in a file. You can modify the line to count to whatever you choose. Let's say I wanted to see the first 15 lines instead. The end flag stands for the number of lines. So wait, ls etc. ls long etc. And now the output of this goes to head. And now I only have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I don't understand what total is. Slash n 5. Let me clear now. Change the number of lines. And similar to head, we have tail. Change the number of lines. Another great option is that you can use f flag. This will follow the file as it grows. Give it a try and see what happens. The system file will be continually changing while you interact with your system. And using tail f, you can see everything that is going to be added to that file. Hold on. So tail log syslog. Okay, tail sample.txt, tail follow sample.txt. So save, save. I don't understand. It didn't do anything. Sample.txt. So it needs to follow the file, right? Tail f, your system log will continually changing while you interact with your system. So variable log syslog. Var log system log. Cannot open this for reading. Yeah, I don't understand. Look at the manual page and read some of the other commands we didn't discuss. So slash f, well, dash f. In our lesson, to cut command, we had our sample.txt file that contained a tab. Normally, tabs would usually show a notable difference, but some text files don't show that well enough. Having tabs in a text file may not be the desired spacing you want. To change your tabs to spaces, use the expand command. So let's check my sample. Okay, so expand sample.txt. That did nothing. Sample.txt, doc2.txt. Now let's look at doc2. Yes, this is tab. And this here is spaces. The command above will print output with each tab converted in a group of spaces. Opposite to expand, we can convert back each group of spaces to tab with the unexpand command. Unexpand A. What happens if you just type expand with no file input? Hold on. Terminal expand. If I do unexpand files, actually notepad. So it changes groups of spaces to tabs. What is the A for? I don't get what the A does. So without the A, hold on, I have another idea. Just read the manual. Unexpand. Convert all blanks instead of just initial blanks. If I do unexpand, actually expand sample.txt and output it into doc2. Let's see, expand. Yep, we converted tabs to spaces. Now we take doc2, unexpand, new document.txt. I think it only changed the leading space maybe. Now let's try all. Yeah, it changed this to tab. To convert tabs to spaces, expand. The join command allows you to join multiple files together by a common field. Let's say I had two files that I wanted to join together. File 1, file 2. See how it joined together my files. So we have John, Jane, Mary, Do, Sue. Now we have John Doe, Jane Doe, Mary Sue. They are joined together by the first field by default. The fields have to be identical. If they are not, you can sort them. What do they mean by identical? Do they mean the same size? So in this case, the files are joined via 1, 2, 3. Oh, this number here. How would we join the file? The following files. To join the file, you need to specify which fields you are joining. In this case, we want field 2 on file text 1 and field 1. So field is the column like in a database. So field 2 and field 1 are joining like with SQL. So the command will look like this. Join. In the first file, you check field 2. The second file, you check field 1. You can split up a file into different files with the split command. This will split it into different files. By default, it will split them once they reach a 1000 line limit. The file's named x star star by default. So what do they mean by split? Split sample.txt files xaa. Okay, let's open the. It did not split anything. Oh, Control W to close a tab. What command would you use to join files named cat dog cow? Join cat dog cow. The sort command is useful for sorting lines. So sort, yeah, b bird. You can also do a reverse sort. You can also sort by numerical value. Sort. Okay, let's take this and put it in doc2. And then, so isn't it already sorted? Sort reverse dot to doc2. Sort reverse doc2. Control W. So this just empties the file. I don't think this would work. Let's try here instead. Sort reverse new document. Okay. To do a reverse sort. Hold on. The translate command allows you to translate a set of characters into another set of characters. Let's try an example of translating all lowercase to uppercase. Translate lowercase to uppercase. As you can see, we made the ranges of A to Z into capital A to capital Z. All text we type that is lowercase gets uppercased. Try the following command. What happens? So wait. Translate A to Z to A to Z. Hello. Okay. So D hello. 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 Okay, it just removes hello. What command is used to translate? It's not really translate, it's more like converting cases. Hold on. tr sample.txt echo sample.txt tr missing of tr wait echo sample.txt tr a to z and a to z echo not echo concatenate. Oh, now it works. The unique command is another useful tool. Let's say you had a file with a lot of duplicates and you want to remove all duplicates. Well, you can use the unique command unique reading.txt and it removes the duplicates. Let's say you want to count how many occurrences of a line, unique count reading.txt. Let's just get unique values. Let's just get unique values. Okay, so this is counting 2 book, 2 paper, 2 article, 1 magazine. Let's just get unique values. So this here, if the count is 1, then output it. Let's just get duplicate values. So unique, duplicate. Unique does not detect duplicate lines unless they are adjacent. Book, paper, article, magazine, article. Unique. Oh, so it won't like shorten it now. Well, would the count still work? Wait, hold on. We have this and I put this here. And then unique duplicate doc2.txt. Is it not going to output anything? Book paper, article, magazine, article. Count. Okay. To overcome this limitation of unique, we can use sort in combination with unique. Okay. So sort doc2.txt and then put the output of this goes to unique C, unique D, and then unique U. What command would you use to remove duplicates in a file? Unique U. To remove duplicates. One magazine. Two. Wouldn't it be this? Sorts slash unique. Sort unique. Is it just unique? Okay. The word count command shows the total number of words in a file. Let's see, word count doc2.txt 7747. It displays the number of lines, number of words, and number of bytes respectively. So I think this is better. 7 lines, 7 words. Let's try sample.txt. Sample.txt. 5, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 113 bytes. Display the number of line. Okay, just to see the count of a certain field, use the L, W, or C respectively. What is the L? L is the line, W is the word, and C is the... What is C? Is it bytes? Why is it C? So L, L, W, C. Why is it C? And number of bytes respectively. Hold on. Manual WC word count, byte count, or C for count. Count by default refers to byte. Print the byte counts. Display the maximum length. Print word counts. M is print character counts. Wait, characters. I'm guessing each character is 1 byte. And then bytes. I'm going to get the total count of lines by using the NN file without searching through the entire output. And use some of the other commands you learned in this course. What command would you use to get the total number of words in a file and just the words? So WC words. Count the total number of lines by using the NL file. Okay, I don't know what the NL file is. The grep command is quite possibly the most common text processing command you will see. It allows you to search files for characters that match a certain pattern. Whatever you wanted to know if file existed in a certain directory, or if you wanted to see if a string was found in a file. You certainly wouldn't dig through each line of text. You would use grep. Let's use our sample.txt as an example. Hold on. So terminal. What is grep? Why is it called grep? I know grep. Searches for patterns. Okay. Let's use a sample.txt as an example. So concatenate sample.txt. Grep sample.txt. Grep sample. Hold on. Control C. Grep fox sample.txt. Quick prompt. Okay, prints the line. OW. You should see that grep found fox in the sample.txt file. You can also grep patterns that are case insensitive with the I flag. So I in case insensitive. You can get even more flexible with grep. You can combine it with other commands with this. So environment, grep I, user. As you can see, grep is pretty versatile. You can even use regular expressions in your patterns. So ls some directory and then grep.txt $. Should return all the files ending with .txt in some directory. What commands would you use to find a certain pattern? And then it's grep. And we are done. I think the advanced one, I wanted to do it this stream, but uh, I've taken more time than usual. So I will just end the stream here. And then I'm guessing later today, I might do the advanced one. That's the plan, but it might change. Anyways, see you guys next stream then. Bye.